Hey Chase, welcome to another video lesson. Today we're carrying on with what I was doing last time, which was exercise 3.8, mixed questions. Okay, and I believe we finished on question 9 last time, so I'm going to start straight off with question 10. And again, I'm going to do this exactly the same as I did the last video. Nice and fast, try to get through as many of these as possible. Hopefully in this video we can finish complex numbers if I rush it. I'm sure we can. So, question 10 says if z, so if a complex number is equal to minus 2 minus 4i, calculate a, the modulus. Okay, the modulus, you'll remember, is yes, like what is your book's notation for a modulus? Well, the modulus we usually call r. Okay, r is the modulus, and r is equal to the square root of a squared plus b squared. And the a and b come from the general form of a complex number, z equals a plus jb. Okay, so if you look at this, if we look at this number here on the left, z, a is minus 2, so you can see that, minus 2 is a, so we've got the square root of minus 2 squared plus, okay, and then b is, so b is the number that sits in front of the j, and you'll see in the general form, b is a plus in front of it. Here we've got minus 4. So b is minus 4. So minus 4 squared, that is equal to the square root of 4 plus 16 is equal to root 20. And that's your final answer. You could also leave it as, what is 20? 20 is root 4 times 5 is equal to 2 root 5. You could also leave it like that. Of course, you could have popped this into a calculator. You don't have to do it all in your head like I just did. Okay, so I just want to rewrite z here for the next question. So b, z equals minus 2 minus j4. Okay, and the next thing they want is the argument. Now you'll remember the argument is, in polar form, we've got r, angle, theta. So here's the modulus, and here is the argument. So theta is equal to tan inverse, or arctan, of b over a is equal to, okay, arctan of b over a. Now, b, once again, b here is minus 4. So it's equal to tan inverse of minus, let's do that in red, minus 4 over a is minus 2. Okay, and that is then equal to tan inverse of minus 4 over minus 2 is equal to 2. And then that is then, we're going to pop that into the calculator. Arctan of 2 is 63,43 degrees. So there we've calculated our argument. Alright, so let's do number C. C says, write the given complex equation in polar form. Okay, well, we know that z was equal to minus 2 minus j4, and that is rectangular form, because it's a plus jb. Okay, and polar form we know is z equals r angle theta, and we've already calculated r and theta, so all we're going to do here is say we're going to use the r and theta we calculated. So r is 2 root 5. 2 root 5. You could also get that in a fraction or in a decimal form if you wanted. 2 root 5 angle 63,43 degrees. And that's it. Illustrate your findings. Okay, so question D says illustrate your findings. D. So show findings on an Argand diagram. Okay, so all they want you to do is draw an Argand diagram and show the modulus and the angle of your point. So here's how I'm going to do it. Let's draw our Argand diagram, and remember the Argand diagram is just the complex Cartesian plane, which is the real part here and the imaginary part here. And we're going to go 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4. Okay. And obviously you should be labeling these. I'm not going to label all of them, but you get the point. You need to label each of those points. Okay, so the first thing, let's draw our point in rectangular form. So over here, there's our point. It's -2 minus J4. So -2 is here on the wheel, and minus J4 is there. So let's draw it there. Okay, and we're just going to draw a line to that point. Okay, so let's label that point. That is -2 minus 4. Okay. That angle doesn't look quite right. Let me double check it here. Maybe we made a mistake. Oh yes, okay. So I'm just going to quickly -2 minus 4. I'm going to check it on the calculator. Okay. So the calculator gives us, for this, it gives 2 root 5 angle -116,57. Okay. Now, what's happened is when we did our module or our argument here, we didn't apply the cast rule. Okay. So we got theta equals 63.43. That's the angle over here. Okay, from the negative x-axis. So you need to be careful to apply the cast rule so that you know what angle you're working with when you calculate your theta. So so as I said, that 63.43 that we calculated is measured from here. Okay, but remember, when we write in polar form, you actually want to write it in with the angle measured from the x-axis. So if we measure from the x-axis over here, that angle is 116,57 degrees. Okay? And we also, in our illustration, we need to include the length of this line, which is r. So we've included the point, we've shown z, we've shown, well, z in rectangular form, so the A and B point, we've shown the angle, and now we just need to show the length of the line, which is r. Then we've shown everything we've calculated, so we can't go wrong. So we're just going to write there, if there was space, write it on the line, but there's not here, so we're just going to write 2 root 5. And you can maybe even say r equals 2 root 5, and theta equals 116,57, negative 116,57. Okay, so there you go, we've illustrated everything on an Argand diagram. Okay, so let's go on with the next question, question 11. Okay, where's my pen? Here we go. Question 11. Oops, what's going on here? 11, there we go. Okay, question 11 says simplify and write in a plus jb form, which is rectangular form. Okay, and then they just give us z is equal to 4 plus 2i into 2 minus I into 1 plus I. Again, multiplication is much easier to do in polar form, but the conversion to polar form, if you don't have a calculator that can do it, is going to take a while. So in that case, it's easier just to multiply it out using the FOIL rule. So it's really up to you. If you get the right calculator, this is going to be much easier. You quickly convert to polar and then do your multiplication and convert back to rectangular. But seeing as you don't have that calculator as yet, I'm just going to do it in the rectangular form. I'll do the multiplication and yeah, I'm just going to do it that way. Alright, so we're just going to use the FOIL rule. So let's start with these first two brackets, and we're just going to carry the last one until we're finished with the first two brackets. So let's do firsts. 4 times 2 is 8. Then we're going to do outers, which is minus I times 4 is minus 4i. Then we're going to do inners. 2i times 2 is plus 4i. And then last, first outers, inners, lasts. Plus 2 times minus I gives minus 2i squared. Okay, and we're just going to pop that into brackets and carry the last bracket because we haven't used that one yet. Okay, so let's simplify this first bracket a little bit. That is equal to 8 minus 4i plus 4i cancels. That's nice. And then minus 2i squared. We know that I squared is equal to minus 1. So this is effectively minus 2 times minus 1, which is equal to 2. So that is just plus 2. Okay. Let me just check my multiplication here. We've got 8 minus 4i plus 4i. Yeah, that's correct. Okay. So now we've got 8 plus 2 and our last bracket 1 plus I. So that is going to be equal to 10 times 1 plus j or I. Don't mix them like I'm mixing them. That's bad practice. So let's multiply the 10 in and we're just left with 10 plus 10 I. And they said write in the form a plus jb. So that is 10 plus j 10. Fantastic. That's question 11 done and dusted. Okay, on to question 12. Let's see how much space we've got left here. Looks like we've still got some. Great. Question 12. They say if z is equal to 1 plus j root 3, calculate a, the modulus. Okay, so we're going to start there. This is similar to the question earlier. So remember the modulus in polar form. We've got r angle theta, and r is the modulus. R is equal to root a squared plus b squared. So to calculate the modulus, we're going to say r equals root a squared plus b squared. Okay, and a is 1 and b here is root 3, because b is the thing that stands by root, or B is the part that belongs to the j. Okay, so r is equal to the square root of 1 squared plus root 3 squared. Okay, so let's simplify that out a little bit. That is equal to the square root of 1 plus root 3 squared is 3. So that's equal to root 4, which is equal to 2. So r is 2. The next question, or next part of the question is B, where they say calculate the argument. The argument is theta. Theta is equal to tan inverse B over A. Okay, so we're going to write there theta is equal to tan inverse B over A, which is root 3 over 1. And let's apply the cast rule, because we didn't do it last time. Okay, so it is CAST. Right. And what quadrant are we in here? Well, root 3, if we look at our Cartesian plane, we've got real and imaginary parts. So the real part is 1, which is somewhere here, and root 3 is somewhere here, so points there. So we are in the first quadrant, and the first quadrant, all trig functions are positive. So we know that theta is going to be positive. Theta is greater than 0, or theta is positive. So let's just pop this into our calculator and we'll get the answer. Theta equals tan inverse of root 3 over 1, which is 60 degrees. Fantastic. Part C says write the given complex equation in polar form. So polar form is r angle theta, or z is equal to r angle theta. We know our r is 2 and theta is 60 degrees. And there we go. And I'm just going to double check myself here using my calculator to do the conversion. 1 plus root 3I, convert that to polar form, is 2 angle 60. Okay, so this is 100%. Right. Let's go on and do question D. Question D says again, illustrate your findings using an Argon diagram. So let's draw it. Here's our Argon diagram. We've got our real axis and our imaginary axis. And once again, you should be putting 1, 2, 3, 4, minus 1, minus 2, minus 3, minus 4, 1, 2, 3, 4, minus 1, minus 2, minus 3, minus 4. Use a ruler when you're drawing this. I can't use a ruler here. So, alright. So now we've got that. So let's first draw in our point, which is 1 plus j root 3. So 1 is on the real axis, and that is over here. There's 1. Root 3 is about 1.7, so it chills there. So let's draw in there. So there's our point. And we draw our line to that point. Okay. And then we're going to label our point, which was, our point is 1 and root 3. Okay. Then let's also label the length of the line, or the modulus, i.e. the r value. And so let's do that. Our r value is 2. So we're just going to put, I've drawn this too small. You should draw this on the line. Just say r equals 2. And then we can illustrate angle theta. Once again, I drew this way too small to fit everything in. Okay, so you're going to draw that there and just say theta equals 60 degrees. And there you go. That's another question done. Question 12 done. And I'm just going to open up a new page for us. It's very hard to draw small using this writing pad on the PC. So I need to actually draw these things bigger in future. I don't want to save my bad. Okay. Open. There we go. Amen. Yes. Let me just pause there and sort this out because now I've saved it. Okay, I've sorted out that that mess that I made. So now hopefully everything is back to normal. Let's give it a shot here. Yeah. Okay, looks good. Okay, I'm just going to save that. Alright, let's get on to question 13. Question 13 says, solve for x if x squared equals x minus 12. This is just a mean way of giving you a normal quadratic equation. So it's just a quadratic equation, remember, ax squared plus bx plus c equals 0. So that's all we need to do. We just got to get this into that form and then solve. So let's do that. So I'm going to keep the x squared on the left. Then we're going to take, no equal sign, x squared. Then we're going to take the x across and the minus 12 across. So it becomes minus x plus 12 is equal to 0. Okay? And now you could try factorize this normally by writing out your two brackets and seeing what you can figure out. But seeing as we're working with complex numbers, it's most likely going to need the quadratic formula to solve. So I'm just going to jump straight into that. So the quadratic formula is x1, 2 equals negative b plus or minus the square root of b squared minus 4ac over 2a. Okay, so let's start plugging in values. B is, look at the general form, b is minus 1, so it's minus 1 plus or minus the square root of b squared, which is minus 1 squared, minus 4, a is 1, c is 12, over 2 times a is 1. So that is equal to 1 plus or minus the square root of negative 1 squared is 1 minus 4 times 12, which is 48, over 2. Okay? And now we're going to pop this into our calculator. You should really get the calculator that can do complex numbers like mine. It will make your life a lot easier. So we've got 1 plus the square root of minus 47 over 2, which gives 0,5 plus or minus 3,43j. And there you go, we've solved for x. So x equals 0,5 plus 3,43j, or x equals 0,5 minus 3,43j. Easy stuff. Alrighty. Let's just double check that everything is correct there. Yeah, all looks good. Okay, so that's question 12 down. Now that was 13. Okay, let's head on to question 14. 14 says, if Z1 equals 3 plus 4, J4, Z2 equals 5 minus J4, and Z3 equals 2 plus J3. Okay, then they say determine Z1 over Z2 plus Z3 in rectangular form. Okay, so what are we going to do for this problem? You can see that there's an addition at the bottom. So here's addition, and then we've also got a division. Okay, so remember, addition / subtraction, it's best to do in rectangular form. Division and multiplication is best to do in polar form. Okay, so we're going to first do this addition. So we're going to step 1. So step 1 is add Z2 and Z3. Okay, then we're going to convert the result to polar form. Then step 2 is convert Z1 to polar form. Then after that we are going to do the division using De Moivre's theorems. And then step 4 is convert back to rectangular form, because the question asks for your answer in rectangular form. So let's start. So this is equal to, let's sub in, 3 plus J4 all over Z2 is 5 minus J4, and Z3 is plus 2 plus J3. Okay, so let's do the addition at the bottom. As I said, that's our first step. So that is going to be, it's equal to 3 plus J4 over 5 plus 2. Remember, we add, when we're doing addition of complex numbers, we add real and imaginary parts. So 5 plus 2 is 7. Okay, we add the reals, then we add the imaginaries. Minus J4 plus J3 is minus J1. Okay. Next step is to convert the top and the bottom to polar form. Now remember, to convert to polar form, let me just find some space to write here. To convert to polar form, what do? We just take the numbers in the form A plus JB, and we convert them to the form R angle theta, where R is equal to the square root of A squared plus B squared, and theta is equal to arctan of B over A. Now I'm going to do these conversions directly on the calculator. I think we've done enough of them for you to know what you're doing there. If you have any questions about it, you're welcome to ask me in class, and then I'll just discuss it with you. Just note which question it is and what your problem was, but it should be pretty chilled. So first I'm going to convert the number at the top. So 3 plus 4i, we're just going to convert that to polar form, which gives 5 angle 53,13. Okay, and that is over, and then we're going to convert the number at the bottom, which is 7 minus 1i, convert that to polar form, and that gives us 5 root 2 angle negative 8,13. Okay, the next step is do the division using De Moivre's theorem. Okay, and remember, De Moivre's theorem for division says that R1 angle theta 1 over R2 angle theta 2 is equal to R1 over R2 angle theta 1 minus theta 2. Easy stuff. So let's do that. So this is going to be equal to 5 over 5 root 2 angle 53,13 minus negative 8,13, which is plus 8,13, okay, which is equal to 1 over root 2 angle 53 plus 8,13, we'll do that on the calculator. 53.13 plus 8.13 is 61.25. And there you go. Now we've got our answer in polar form. This is our final answer in polar form. But the question asked for rectangular form, so we're going to convert back to rectangular form. So, to convert to rectangular form, we take r angle theta, and we're going to go to the form a plus jb, where a is r cos theta and b is r sine theta. Again, I'm just going to do this on my calculator. You've got the formulas there, you can try it yourself. And if you have any problems, you're welcome to ask me, but I'm just going to do it on my calculator here. So 1 over root 2 angle 61.25 degrees, and we're going to convert that to rectangular form. And our answer is, let's see here, 0.34 plus j 0.62. And there you go. There's your final answer for question 14. Alright, let's move on. Okay, next question is question 15. But I'm actually going to leave this one up to you to do, because it's almost exactly the same as question 4. So you can go back to my video on question 4 and do the exact same thing, and you should be able to get the answer for it. Shouldn't be a problem. And the final answer is in your book, I believe, so you can check yourself. So just refer back to my video on question 4, and then you'll see how to do question 15. Okay. Okay, the next question here is question 16. It's quite interesting. It says calculate the standard form of z if z minus I squared equals 1 over 1 plus I cubed. So what they're basically saying by saying calculate the standard form of z if that, they're saying write this equation, in the form z equals a plus jb, because that's the standard form. So let's do that, and all we're going to do is we're just going to start simplifying, and we're going to work through it until we get to where we need to be. Okay, so first thing, I squared is equal to negative 1. So this becomes z plus 1 is equal to 1 over 1 plus I cubed is negative 1, wrong, square root negative 1 times square root negative 1, square root negative 1. Okay, if we multiply that out, that gives negative 1. We multiply these two brackets, negative 1 times root negative 1, which is equal to negative j. Okay, so we've already simplified that. This becomes 1 minus j. Okay, next thing, let's take this one across, get the z by itself, which is what we want. So it's z equals 1 over 1 minus j minus 1. Okay, now the next thing that we're going to have to do is get this all onto a common base. Okay, so in order to do that, we're going to have 1 over 1 minus j, and we're going to multiply this in order to get it on top of this fraction, we're just going to multiply it by 1 minus j. So that's minus 1 into 1 minus j. Okay, so z is equal to 1 minus, let's multiply at the top, 1 minus 1 plus j over 1 minus j. Yeah, that's correct. So 1 minus 1 cancels out, and we're left with j over 1 minus j is equal to z. So now, okay, so lovely, we've got an alarm going off in the background there. Okay, so now in order to get this to standard form, what are we going to do? We're going to use rationalizing. Okay, rationalize. So when we rationalize, what do? We multiply by the complex conjugate of the denominator over the complex conjugate of the denominator. So j over 1 minus j times 1 plus j over 1 plus j. Okay, and that is equal to, so let's multiply at the top, j plus j squared over, multiply at the bottoms, we're going to use FOIL, which gives firsts is 1 times 1, outers is j plus j, inners is minus j, lasts is minus j squared. Okay, and we can just carry on simplifying, and we're almost out of space. So j squared is minus 1 plus j over, plus j and minus j cancelled, and minus j squared is equal to minus negative 1 is equal to plus 1. So we've got 1 plus 1. That is equal to minus 1 plus j all over 2, which is equal to minus 0,5 plus 0,5 j, and that is in the form, let's just put our z here, z equals, so that is in the form a plus jd. So we are done. That is the end of question 16. So let me quickly open another blank document here. Here we go. And let's quickly make sure I'm at the top of the page here. Okay. So question 17, probably going to give this one a skip. 17 says, it just gives you 3 complex numbers in rectangular form, so it gives you z1, z2, z3, and says determine z1 plus z2 plus z3. So for question 17, just add real and imaginary parts and leave in the form a plus jb. Okay, so that's question 17. Very simple, really not worth doing here. Okay, question 18 says, it's another solve for x and y question. Very similar to question 9. So 18 says, solve for x and y, and the equation is 7x plus 3yi is equal to 4 minus 3i over 3 minus 3i. Okay, and that's it. That's all we have to do. So let's get cracking here. Okay, So basically, once again here, all we've got to do is separate. Do you see that we've got a real part here that belongs to x? So there's our real part. And we've also got an imaginary part. The imaginary part is 3y, and the real part is 7x. And on the left side, all we need to do is get this into a real part and an imaginary part, or an a plus jb form. Okay, so we need to get this side into the form a plus jb, and then we'll be sorted. How are we going to get it into the form a plus jb? We're going to rationalize, again, just like we did in the last question. So, we're going to rationalize. And what are we going to do? We're going to multiply by the conjugate of the denominator over the conjugate of the denominator. So, let's do it. We've got 4 minus j3 over 3 minus j3 times 3 plus j3. Remember the complex conjugate, you just change the sign in front of the imaginary part, over 3 plus j3. And then we're going to multiply this out using FOIL. So let's multiply the top. We've got firsts, which is 4 times 3, which is 12. Outers is 4 times j3, which is plus j12. Firsts, we've done outers. Let's do the inners. Minus j3 times 3 is minus j9. Then the lasts is minus j3 times minus j3, which is minus j squared 9. Okay? Over. Now we've got to do the same thing at the bottom. So first is 3 times 3, which is 9. Outers is 3 times j3 is plus j9. Inners is minus j9. Lasts is minus j3 times plus j3, which is minus j squared 9. Okay, that is equal to. Now let's simplify the top and the bottom. So we've got 12 plus j12 minus j9 is plus j3 minus j squared is minus 1, so it's minus times minus 1 times 9, which is plus 9, over 9 plus j9 and minus j9 cancel, and then we've got minus times j squared, so minus 1 times minus 1 times 9, which is plus 9. Sorry. There we go. Let's simplify a little bit further. That is equal to 12 plus 9 is 21. 21 plus j3 over 18. And now let's not forget about our left hand side. We had 7x plus j3y. Okay. So now we can write this in the form a plus jb. This piece on the right hand side we put into the form a plus jb. So we've got 21 over 18 plus j 3 over 18. Okay? And now we can separate into real and imaginary parts. Okay? So let's do that. The real part is the stuff without the j's. So the real part is, on the left we have 7x, and on the right we have 21 over 18. So 7x equals 21 over 18, and on the right we've got j3y is equal to j3 over 18. But we already know it's the imaginary part, so we can ditch the j's, and we have 3y is equal to 3 over 18. Easy stuff. Now we've got to solve for x and y. That's what they asked us to do. So let's solve for x here on the left. So x equals, we're just going to divide by 7, 21 over 18 times 7. And here we've got y equals 3 over 3 times 18, which is equal to, that cancels with that, 1 over 18 is y, and x we have 21 divided by 7 is 3 over 18, which is equal to 1 over 6. And there you go, you've solved for x and y. And that's question 18 done and dusted. Okay, question 19. 19, nice and easy, it just says simplify. Okay, and what we need to simplify is 4i cubed minus I to the 4 over 2I to the 5. Okay, so I is equal to root minus 1. I squared equals root minus 1 times root minus 1 is equal to negative 1. I cubed equals I squared times I, which is therefore equal to, from these two above us, it's going to be equal to minus I. I to the 4 is going to be equal to I squared times I squared, which is equal to minus 1 times minus 1, which is equal to 1. And thereafter it repeats. So I to the 5 is equal to I to the 6 is going to be equal to I squared, I to the 7 is I cubed, and so on. So now that we know that, let's do this. So we start simplifying. 4I cubed, well, we know I cubed is just negative I, so that becomes negative 4I minus I to the 4 is 1 over 2 times I to the 5 is I. Okay, so now we know that. Once again, in order to get it into standard form or A plus JB form, we're going to rationalize. Okay, so let's quickly rationalize this. Minus 4I minus 1 over 2I. And remember, we multiply by complex conjugate over complex conjugates. Okay, and let's quickly multiply that out. Minus 4I times minus 2I gives us 8I squared. Minus 1 times minus 2I is plus 2I over 2I times minus 2I is minus 4I squared. Let's simplify that a little bit further. I squared we know is minus 1, so that gives minus 8 plus 2I over minus 4 times I squared, which is minus 1, over 4 is equal to minus 2 plus, so the real part is minus 8 over 4, which is minus 2, and 2I over 4, which is 0,5I. And there you go. There's your answer. It's in standard form, and you've simplified the equation. Okay, drawing to a close here. Question 20. This says, determine the modulus and argument of z, and it gives you a complex number, and present your findings on an argument diagram. We've already done, I think, 2 of those, so I'm not going to do another one now. You can just refer back. Okay, so for 20, just if you're battling, just refer to questions 10 and 12. 10 and 12, and that'll show you the method. And then just check if you get the right answer there. Okay. Question 21. Okay, question 21. It says, use complex numbers to calculate the resultant of 3 pulling forces of 50 newtons east, 80 newtons east, 30 degrees north, and 120 newtons at 45 degrees or west 45 degrees north that act on a point. Okay. For this one, I think we'll do this one in class together if you battle with it. In class. Yeah. So that one we'll wait. We'll do that one in class. So that we can be clear about these directions and whatever, and make sure that everyone understands. And then question 22 says solve for x in the equation x cubed minus 8 is equal to 0. Okay, now that's a bit of an interesting one, because here you can't use the quadratic formula because this is now a cubic equation. But what can we do here? See, we can find one solution for x by saying, the method to do this is not in your book, it's not covered. So I don't know how they can be asking you this. This question requires long division. And it's going to take me a while to explain long division. I can't just explain it now. Okay, so because it's a cubic equation, there are going to be 3 roots. Okay, 3 roots. We can find one root by taking the 8 across. So we have x cubed equals 8. X equals cube root of 8 is equal to 2. Okay, so that's our one root. So let me just carry on somewhere else. Okay, so we know that x equals 2. So that's the one root. So one root is x minus 2. Okay, but the equation is x cubed minus 8 equals 0. Because of the cube, there's going to be 3 roots. So now we have to do something called long division, I believe. But there's no method in your book that teaches you how to do it. So I'm going to give it a shot here, and we'll see how it goes. So we've got x cubed minus 8 divided by x minus 2. Okay, so x goes into x cubed, x squared times. Multiply, x squared times x gives x cubed. X squared minus 1, or x squared times minus 1 gives minus x squared. Okay, then we change the signs of these and subtract them. Those cancel, and we have x squared minus 8. Okay, now x goes into x squared. How many times? It goes in x times. X times x squared is x squared. X times minus 1 is minus x. We go minus and a plus, and those two cancel, and we're left with x minus 8. Okay, x goes into x how many times? Goes in 1 time, plus 1 time. Okay, and we've got multiply x minus 1, change the signs, those cancel, and we're left with minus 8 plus 1 is minus 7. So that's our remainder, minus 7. So this doesn't look like it's going to be solved this way. That's because I made a mistake. I'm sorry. Let me redo that. I divided by x minus 1. I should have been using this root, which is minus 2. So I'm just going to erase that, and I'm going to do it again. Sorry about that. Okay, let's start again. Okay, see if I can get it right the second time. So we've got x minus 2 into x cubed minus 8. Okay, so once again, x goes into x cubed, x squared times, then we multiply. x squared times x is x cubed, x squared times minus 2 is minus 2x squared. Then we change the signs here and subtract, those cancel, which leaves us with plus 2x squared minus 8. X goes into 2x squared, 2x times, multiply out, that gives 2x squared plus 2x squared minus 4x. Okay, change the signs, so that's minus, plus, and do the addition, those cancel, and we're left with 4x minus 8. Okay, now x goes into 4x times, 4 times, so 4 times x squared gives 4x, 4 times minus 2 gives minus 8, change the signs, and they cancel, everything cancels. So, now the roots of this equation, so now we know that x cubed minus 8 equals 0, which means that x minus 2 into x squared plus 2x plus 4 equals 0. So now we've got one root here. We've just got to get the other two roots, and for that we're going to use the quadratic formula, which is negative b plus or minus the square root of b squared minus 4ac over 2a. Okay, and let's substitute in. So we're doing it for this piece of the equation, remember. So it is minus 2 plus or minus the square root of 2 squared minus 4 times a is 1 times c is 4 over 2, which is equal to minus 1 plus or minus the square root of 4 minus 16 all over 2, which is equal to minus 1 plus or minus the square root of negative 9 over 2, which is minus 1 over 2 plus or minus the square root of, oh no, we can ditch the square root, plus or minus 3j over 2. So there we go, we know that it's equal to minus 1 over 2 plus or minus 3 over 2j. Okay, so now we've gotten the one root, and now we've solved with the quadratic equation, we've solved the roots here. So now we know that from the first root, x equals 2, or x equals 1 over 2 plus j 3 over 2, or x equals 1 over 2 minus j 3 over 2. It's a cubic equation, therefore we've got 3 x's, and that is the answer. If I know that the long division thing might be new to you, I'll have to explain that to you in person. It's a bit difficult to explain over this video, so I'll explain it to you in person if you're battling with that. You might remember it from high school. But yeah, there you go. We've got the solution to this question 22, and that's the end of the video lesson. Thank you very much for watching. Cheers.